Okay, Mr. Kolesnick, we're going to be talking about MS1, Lesson 1. Um, Trying to work this out as best we can with the equipment we've got, so bear with me. Sometimes you're going to have to listen really hard or go through it once or twice. What really is going to count here is what's written on the board. All right. Now, I wanted to have the bright lit back screen so that we could actually look at it and investigate it and go back through it. As you know, I've given you videos to learn already on our site. So you get a lot of options in regards to learning how to do it when you grab your Go Math Middle School Grade 8. Now, so I'm going to use the Teacher's Edition. That's only because I happen to grab the Math 7 one to start out by looking at it. So, but I'm going to the same page as you're going to. So when I go to Module 1, it's the same module that you have. So we say 1 in real numbers. Okay? So, page I'm starting on is page 7. And page 7 says this is rational and irrational numbers. And having said that, it first talks about expressing rational numbers. And if you look at example 1, and that's example 1A, it talks about 1/4. And when it talks about 1/4, it's telling you that 1/4 is is 1. Notice I put the zeros there to actually break this thing out. Divided by 4, which means, and some of the stuff I'm going to show you is stuff to keep you out of trouble when you get into bigger math. You're going to be going on to Algebra 1 next year, then you're going to go on to geometry, then you're going to go on to Algebra 2. It's important that you have systems that will work for you. So, 4 does not go into 1. 4 goes into 10 2 times. Do this the long-fashioned way. This is an 8. This is a 0. We now have 2 at the bottom. Now we're going to go down here and we're going to say 20, right? How many times is 4? Go into 20? 5 times. And we're done. So, 1/4 equals 25 100ths. All right, now, so if we move on to example B on the bottom of the page, it talks about 1 divided by 3. So 1 divided by 3 is going to look a little different than this. It's going to look like 1 divided by 3 is going to look like this. And some of you already know this from 7th grade, of course, that 1 divided by 3 is 3 won't go into 1. Make sure you've got that placeholder there of 0. 3, 3, 3, 3, and you could go on forever with that. So we put a line up at the top. Okay. Now, we also want to be able to take decimals and express as rational numbers. So, to clear this all off, you can go back and get this just as easy as play playing that video again. Let's just do it. And this is on page 8. My plan is to always let you know what page I'm on before I start writing. Now, of course, there's a couple of U-turns up on the top. Your turns are up there. Talks about 5/11ths, 1/8, 2 1/3. You'll figure it out. Try not to do a lot with a calculator. Not learning a whole lot by that. So now what we're going to look at is we're going to look at 825 divided by 1,000. Example A. Back in 7th grade, you should have learned that the way to do this is to take a look at it and find a common denominator. So what's a good common denominator to try for 825 and 1,000? What's common between the two of them? You can divide it by and make that number smaller on the top and on the bottom accurately. When you look at that, you're probably going to say, I want to use a 5. Using a 5 is okay, but it isn't quite right. Because actually, when I look at this, I think the common denominator for this should be 25. Now, that might not be the last stop on this train, but it should make our numbers small enough that we can look at them and make some good use out of them. So what we're going to do is we're going to take 825 and divide that by 25. And we're going to take 1,000 and divide that by 25. Now, what I want you to understand here is that this statement, mathematically, is saying this: 825 divided by 1,000 divided by 25 over 25, or 825 divided by 1,000 divided by 1. We can divide anything we want by 1, and it'll still be the same value. The numbers will change, the value will stay, is what we're going to reduce. So we're reducing the value of the top and the bottom. And if we do that in an intelligent fashion, just like I'm describing here, we will find that 825 thousandths, let's write that as a decimal, is equal to 33 40ths. Now, if you hit your calculator and you divide 33 by 40, you're going to get 0.825, which again is equal to 825 thousandths. 825 thousandths. Check. So, let's try that a little bit differently. Let's look at still on page 8, 0.37 with that good old bar on top. This one looks tough. This one looks like it could be difficult. Could take a while to get through. But it's a little easier than that because we have a system designed just for this. Now, if you look on page 8, what it's telling you is that we're going to use a little bit of algebra. X is equal to 0.37 forever. All right? Once we know that, if I multiply the left side by 100 and I multiply the right side by 100, this is what I get. In your brain, work with it a little bit. This can be a little bit challenging, but once you look at that, you now know that this has to be true once we do this. Because that going on forever doesn't go away. It's going to go on forever. And it's going to go on forever. And it's going to go on forever. So I want to subtract x from this. Remember, x is equal to 37 forever. I want to subtract x from this, which means I'm going to have this, 90x, right? Excuse me, 99x. Sorry about that. 99x. You see that 100 x's, 100 xylophones, minus 1x, 1 xylophone. I'll have 99 xylophones, right? Well, that means since x is equal to this, what do I have after I subtract? 37 goes on forever. Give that a moment to ruminate in your head. This is an important step for you as 8th graders. We're going to see problems that'll work out pretty much this way. I'm going to get rid of this from this value by subtracting x. Isn't that what that means? No. That's not the answer I'm looking for. I'm not looking for the answer, what's 99x equal? I'm looking for the answer, what's x equal? So immediately I know I need to do this, right? And that'll give me x. Kind of elegant. And I really want to do this well because I want to make sure that you have this in your brain and in your toolbox to be able to use it when you see something that looks like it's going to be ugly. It's really not that ugly. Because if I did that on this side to get x, I have to do the same thing to the other side to get 37. You'll notice at the bottom of the page on page 8, that's what it tells you. Now, we're going to talk about finding square roots and cube roots in our next lesson, which is beginning on page 9 and page 10. I think you can read that and get through that and go right ahead and do the work on page, bottom of the page, on page 10, do your turn. Page 12, 13, and 14. Don't worry about the hots. We're okay with that. Okay? So head on that path. And after you come up with problems in class, let me know. We'll work it out. All right? But I want you to start working on the guided practice page 12, 13, and 14. And let me put that up here. And clarity for you. Finish. age 12, 13, 14. I will tell you, I would suggest 10 and 11 as well because those will help you be sure to get through this. Good luck, and we'll keep it together in class. Thanks, guys.